for today's lesson, we're going to do 3 different types of quadratic application problems. We're going to study quadratics as they apply to geometry, as they would apply to finance, and then we've already done a little bit of it, but we're going to apply it to physics and engineering. Remember when we talked about throwing things and dropping things? We're going to bring those problems back up again, just because I noticed on the test some of you could use like a little bit of an extra push on those. So we're going to hit those one more time before we take our test next week. Your homework assignment, you'll notice that there's 10 problems in this packet. For right now, what we don't finish is homework. So you're going to see that I do some, and then you do some, and then I do some, and then you do some. So that's how we're going to kind of work it, and then whatever is left over is yours for homework tonight. I will also go ahead and let you know that I worked out all of these problems for you. So when you leave me today, I'm going to run down to the copier. I'm going to scan my packet in, and I'm going to upload it to Blackboard for you. And that way, if you're looking at a word problem tonight and you're like, oh, I don't even know how to start it, or, oh, I got something that's not factorable and we were factoring in class today, you can kind of just look that up and kind of see maybe how our numbers are different. You can look at your work and kind of see how you're doing. So I obviously couldn't copy this and pass it out, but I did want you to have access to the work and the answer so that you could kind of check. Please just log into Blackboard to check your work tonight. So I ask that you do that as part of your assignment. Okay, so we have some steps to doing word problems. You've seen these steps before, hopefully. We actually did them on our second day together, I think. You got a handout on day 2 of Honors Algebra 2, Steps for Attacking Word Problems. And I won't even lie, I love cut, copy, paste. So that's what I did. I went back to that handout. I just copied the directions from that. And I need you to help me fill in those blanks. So let's see what you remember. Do you remember, Tamara? Yeah, step 1, read the problem thoroughly. Read it again if needed. Some of you are going to have to do that. It doesn't mean that you're less intelligent if you have to read it 2, 3, 4, 5 times. That's normal. So don't beat yourself up for having to read the problem again. Step 2, identify your, Sydney? Yeah, very good. Identify your knowns and your unknowns. When we do the geometry problems, I find it super helpful to draw a picture of whatever shape or shapes we might be looking at. So that's why I added that in. If we're doing the finance problems or the physics problems, sometimes it's not a bad idea to try to produce like a table of values that would get us a parabola to plot, like those T-charts to make a parabola. So you could draw a picture to help you, long story short there. Step 3, declare your what? Dom, your variables, very good. A little hint, usually it's in the last sentence or sentences of your problem. Step 4, we write a blank blank. Yeah, very good, verbal model. This is kind of like our bridge from what was the word problem to the equation. I know a lot of you put a lot of pressure on yourselves to just look at a problem and write an equation right away, but that doesn't always happen. You have to give yourself a couple of steps ahead of time to be able to write that equation effectively. I really recommend writing a verbal model. It's like a quasi, like there's some words in it and some symbols in it, and then you fill in those words, and we write a, step 5, Hannah, an equation. Very good. So you're going to use this model to build your equation. Step 6, we solve and we check. When we do word problems, quite often that comes in the form of, does this answer make sense? So you look back at your problem and you're like, Ma, does this seem right? On your test, some of you might have looked back like, we were dropping something from 382 feet and we wanted to figure out what time it hit 370 feet. Some of you had like 8 seconds, things like that. To fall 12 feet, 8 seconds. You might look at that and be like, oh, that sounds a little long. So I really recommend just going and looking at your answer and be like, oh, does that make sense? And then if it doesn't, try it again. 7. We write our answer as a sentence when we do word problems. That's so that you can definitely answer the question. Leave no stone unturned. Questions about our steps for today. All right, giddy up, let's do it. Ooh, forgot to erase it. Sorry. This was in the news last week, 2 weeks ago. And so I stole it. Well, and then I added a little bit of stuff to make the numbers work out nice. So I know, I plagiarized. Okay. Have you heard about this though? We'll read it together. You let me know if you've heard about it. True story, McCandless Township is actually talking about building a wetland. Making a wetland. Where that Rave Cinemas is. Did you hear about that? Do you know where the Rave Cinemas is? Across from like the Target and stuff? Okay, so they're talking about tearing that down and making it like a nature preserve. I think this is all in part with like the Walmart coming in and stuff like that. So McCandless Township is talking about building, I called it a nature preserve, of sorts on the site of the old movie theater. I just estimated to make the numbers work out nice. I wanted to say that that movie theater was maybe like 180 feet by 120 feet. I was like, oh, that's 60 yards, a little bit more than half a football field. I thought that that might be kind of close to the size of that movie theater. And yet the numbers will work out nice for you in Algebra 2. So I was like, oh, 180 feet by 120 feet. If McCandless Township were to purchase the parking lot around that theater, you know where like the park and ride is, if they were to buy that too, because that's also on the table, if the township were to purchase that parking lot around the theater, it could double the size of that wetland, double the area of that wetland. There would be enough additional space from the parking lot to add the same distance to both the length and the width of the movie theater. So they could go out from the movie theater as far as they go off to the side. What we're asked to figure out then is how much extra length would they actually gain going out and to the side of the movie theater. So to be clear, how much extra length would be gained? And then what would the new dimensions, length by width, of that movie theater and the parking lot, aka the new nature preserve, what would the dimensions of that be? Okay, so in listing out our knowns and our unknowns, does anybody need me to read it again? I kind of ad-libbed a little bit through that too. Okay. In moving into step 2 and even a little bit into step 3, when we go to list out our knowns and our unknowns, I see a picture popping up in my head. I don't know if you see it. Anybody got a general shape in their mind about what we're looking at here? Is it a circle? Is it a triangle? What are we looking at, Dom? You're saying a rectangle? Me too. What a coincidence. I'm honestly seeing a rectangle inside a rectangle. You see it? Maybe? Maybe? Okay. So this is how, when I do a geometry problem, I go about listing my knowns and my unknowns. I actually just draw a picture. So Dom said he sees a rectangle. Ooh, I'm going to draw it in a slightly different spot. I'm going to call this the movie theater. It is Rave Cinemas. And this movie theater is 180 by 120 feet. Everything's in feet. That's important. We really can't do any of these problems unless the units are all the same. So I know that. Eventually that would give me the dimensions, or the area rather, for the entire movie theater. So I can think about that in just a second. What I also know is that they're going to add on, there's like a parking lot behind the Rave Theater, so they're going to add on some distance here, and they're going to add on, like this is where the park and ride would be, you know, like the PAT buses all like line up over here. They're going to add on the same distance here and here, and I don't know what that distance is. I don't know how far out that goes. So that's something I don't know. I call it X. When I don't know something in math class, I often call it X. And so when I said, hey, I see a rectangle inside a rectangle, that's kind of what I meant. I know a little more than that. Does anybody see a fact that I overlooked? My clock's wrong, Caitlin, I'm sorry. I think it's 10:02, yeah, I think. I don't know what happened there. Yeah, thanks. Tamara. So I got that because I added on the same distance. Do you see how I called it x and x, not x and y? The same distance got added onto both. There's actually another thing hiding out in there, Michael. Yeah, we're doubling the area. So I should probably figure out what the original area of this cinema was and then double that area, right? So that'd be 180 by 120. So this area, music to my ears, y'all sliding your calculators open, good job. So 21,600 square feet is the movie theater, which I also thought sounded kind of big enough. And then I would double this because that's going to be the area that they're hoping to have for this whole wetland project. And this is all in my estimation, of course, making the numbers nice for Honors Algebra 2. So we're looking at a new area. This is all encompassing, by the way. So I'll highlight it. This would be the area of this whole rectangle here. The whole thing, including that rave cinema. I think I got all the facts in there. I listed out all my knowns and my unknowns, and they're on a picture. Okay, so now it's time to develop a verbal model. Ultimately, we're asked to find the new dimensions of the nature preserve. So what we're going to have, when I think dimensions, I think length times width, right? So we're going to have a new length times a new width. And this would get me that double the area, or this was our new area, we'll call it. To make it official, we didn't declare our variable. That is something we would have to do. X in this case, when we go to declare our variables, X is going to represent what we don't know about the problem. We don't know the extra length gained in feet. So I have a new length times a new width, and that gives me my new area. This is totally one of those lessons where you need to like understand what you're writing. If I put a number up there, or if I write a word and you're like, why is that? Just ask. Everybody good so far? Looks like you're good. Okay, so now I need to fill in some bits of this verbal model with either numbers or variable expressions. Can anybody fill in one of those three blanks for me? Ooh, Sydney. Yeah, very good. The new area is 43,200 square feet, sorry. What's the new length, Dom? Good job. Or x plus 180. We wrote it in standard form. How'd you get that? Yeah, they're not like terms, you know, you can't synthesize them, you have to put them together. New width, Maddie. Yeah. And so now we have a quadratic equation that we could solve. I'm thinking most of you at this point would probably FOIL the right side, so I'll do that. So 120x and 180x, that's 300x. And then 120 times 180 from earlier in the lesson is 21,600 square feet. So this might have been like a question on your last test, you know? We would probably go ahead and take a second to try to solve this. You could solve it by completing the square, the quadratic formula, factoring. We have lots of different ways that we could try to go ahead and solve this problem. Outside of completing the square, however, step one in the other methods would have us getting one side equal to 0. So I'm going to go ahead and do that. I do that by just subtracting 43,200 from both sides. So I would have to now subtract 43,200 from 21,600. That's just going to give me negative 21,600. You have options. You do. We now need to solve this for x. What are you thinking? I'm just curious. Can we take a vote real quick? Honestly, this is totally an opinion question. There's no right or wrong answer. Right now, we could use 3 of our 4 methods. Can't use the square root method on this thing just yet. Who would try to complete the square on this? A couple of you. Who would do the quadratic formula? Who would factor it? The other half. Yeah, okay. Okay, so either way, quadratic formula, completing the square, all of them would work. You could do what you want. I know this is factorable. I'm going to go ahead and factor it. But you got to do what occurs naturally to you. I actually know that there are factors of negative 21,600 that could make 300. Did anybody get them already? You're going to take a second guess and check it. Hannah. Yeah, nice. So now, this is an intercept form. P is 60, Q is negative 360. I'm going to go ahead and use the zero product property for emphasis. I actually kind of already know that if I set x minus 60 equal to 0, that'll give me one possible answer for x. Add 60 to both sides. Here I could set x plus 360 equal to 0, subtract 360 from both sides. And then now I'm hitting that step of the problem, or the problem-solving process where I'm like, which answer makes sense? Yeah, not the negative one. Once again, that's not going to work out. You're not going to double the area of this wetland project. By subtracting 360, it's not even possible. So we typically do attach some units to this. So they're going to be able to double the area of this wetland or nature preserve by adding 60 feet onto the new width and 60 feet onto the new length. It's always a good idea to go back and make sure you answer the question. We also usually, when we answer a word problem, we write our answer as a sentence to be clear. So let's go back and do that. It said, how much extra length would be gained? Can anybody give me their sentence to answer that question? Go, Maddie. Yes, very good. And then it also asks us, what would the new dimensions of this nature preserve be? Go ahead, Hannah. Perfect. 240 feet by 180 feet. Is there questions about this one? Okay, next up. These are going to be problems that you're going to try at home. So it says you try it. Yay! But not just yet. I want to kind of give you a nice sampling of the different types of problems you have to take care of. So, yeah, you get some sampling. It's like Sam's Club on a Saturday. Just kidding. Sorry, I didn't get enough time to erase for my last period. Okay. True story, we could apply our understand. Do you guys see where we're at? Now, next application is in the world of finance. Step one, we read it and we read it again. We have a go-kart problem. A go-kart track has about 380 racers per week and charges each racer $35 to race. Pricey go-kart track. I don't know what the going rate is for go-karts lately, but seems steep. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. How can the owner of the go-kart track maximize his weekly revenue? Maximize his weekly revenue. What's that remind you of? What's that word remind you of? The what? Okay. When I see maximum in this chapter, I think of parabolas, right? Is there a certain point that helps us identify a maximum? Selena. The vertex. So slightly different skill set here. Do you see how we're finding, on the first problem we worked to find intercepts. On this problem, however, we're probably going to have to think about the different ways that we could find a vertex. It's not a bad idea to have your pink paper out on what I need to know about parabolas. So if you're a person who has trouble figuring out, like, based on the form that you're looking at, how do you find that vertex, it's good to have that pink paper out. So you can go ahead and take that out. So this isn't a geometry problem. I'm not going to draw a picture for it, but I am going to go ahead and take some time right now to list out what I know, list out what I don't. Yeah, right? I got a coupon. No. So what are some things that you know about the problem? Got it, Michael? Ooh, okay. So what I can pull from your little bit of information there is that the original number of racers that this guy's going to bring in at 35 bucks a pop is 380. So I'll say my original number of racers is 380. And then the original charge per racer is 35 bucks. What else? Dom.
There will be 20 more races per week for every $1 reduction.
Okay. So we get to increase, or we have rather, can't spell, an increase in the number of racers by 20. And when does that happen? When we decrease, so we increase, when we decrease the price by $1. So those are things that we know. What do we not know? There's actually two things we don't know if you think about it. Remember, you could always look to the last sentence to help you figure out what we don't know. Now I see some hands. Let's hear Hannah. Let's see. Weekly revenue. Originally, we could figure that out, right? How would you figure out? You're kind of segueing into actually the next step, that verbal model. But how do you figure out revenue, Hannah? Do you know? It is the total amount of money that comes in, but how would we make that calculation? You're like going blind in the sun back there, too. It's hard to say. You could think about that. Yes, we don't know how many weeks. And why is that important to know? Yep. Right. Okay. So the number of weeks affects the price. Very good. So the number of weeks actually tells us how many times this guy needs to reduce his price. I'm saying a guy. I don't know who owns this, honestly. So I don't know a whole backstory on this particular problem. But yeah, we don't know a number of weeks. And the number of weeks actually helps us determine our number of price reductions. How many times does this guy have to knock $1 off his price in order to maximize his revenue? Which is our next question. Number of price reductions. Everybody see that? Don't write it down if it doesn't make sense. Do you see how we don't know that? And you could think about it as a number of weeks if you would like. But that's because the number of weeks tells us how many times he's going to reduce his price. The number of price reductions that he goes through, or the number of weeks that he goes through, ultimately affects what? That's the other value we don't know. So if x is a control variable, what is it affecting? Sydney. Yes, which then affects his, we're trying to maximize the revenue. It's putting, yes, it affects the number of people that comes in, that's true, but ultimately what we don't, the other thing we don't know about the problem is like, what is his maximum revenue? We're going to try to answer that, right? Questions about that? Now, what I hear from all of your answers thus far is that revenue, this is us writing our verbal model, comes from multiplying two things together. Originally, he's bringing in 380 racers at $35 per racer. So what two things do I need to multiply together in order to figure out his weekly revenue in general, Michael? I'm talking generally speaking, because that's not always, it's not always going to be 35 times 380, or else I'd just be done with the problem. I'm looking for, like, what things do you multiply together in general to give you revenue? Ooh, a couple people know. Selena? Yeah. The number of racers times how much it costs each racer to go on the go-karts. The charge per racer. So, Michael, do you see how? But what I like about your answer is that it sets me up pretty sweetly for the next step. I know that I don't know revenue. That's going to be our Y value. Initially, we start with 380 racers. And if I want to find the initial revenue that this guy brings in, I would have to take 380 and multiply that number by $35 per racer. So that gives me like a baseline of how much money he would originally bring in. But as I said to Michael, I was like, I need a general thing because these numbers are going to change. So in general, my first quantity represents a number of racers or a number of people. My question now is this number of racers or number of people going to increase or decrease? Dumb. Increase. So I have to add something on to that. So I get a plus sign in that set of parentheses. Let's look at the second set of parentheses. The charge per racer. Am I going to add money onto that $35? Or in this problem, are we taking away money? Subtracting. Very good. So I have a plus and a minus. Everybody see why those symbols are there? Okay, so now we have to go back to what Hannah was saying with this whole X thing. X could be a number of weeks, or you could think about it as a number of price reductions that this model goes through, or this problem goes through. Keep in mind, I'm supposed to get, this is where this sentence is kind of coming in right now, we're supposed to increase, we're going to increase our number of racers by 20 more racers per week. 20 more racers per week. For every $1, we reduce the price. What am I going to add on to that 380, Maddie? It would be 20x. Very good. And now the charge per racer. Sydney. Yeah, very good. We're going to take off $1x. Real quick, I want to lob this out to you because you're going to have to do a couple of these tonight for sure. Let's say he wanted to reduce the price by $2 per racer. How would Sydney's answer change? It would just be 2x. Let's do it again to make sure everybody understands. Let's say I wanted to reduce the price to 50 cents or by 50 cents per racer. Yeah, 0.5x. Does everybody see how that comes about? Because in the other problems that you do, it's not like $1. It could be $20 or it could be 50 cents. So we keep our money together in its set of parentheses and our number of people or songs or albums or whatever it is in the other quantity. So you want to isolate those. All right. So now this is an equation that we could solve. Let's keep in mind what we're trying to find. You kind of said it a little bit ago. We're trying to maximize the weekly revenue. So now we need to take steps to identify specifically, if this is a quadratic, we need to identify what we call the vertex. There are two different ways you could find this vertex. What's occurring to you to do? What do you think, Dom? You want to FOIL it, get it in standard form? All right, let's do that. So we're going to take some steps now to find the vertex. Dom wants to get the equation in standard form, so let's do that. So you're going to grab your calculator, FOIL it out a little bit. So when we FOIL it, we get y equals negative 20x squared plus 320x plus 13,300. So when you look at your pink paper, if we want to maximize this function, first of all, I can tell I'm able to find a max because my a value is negative. This parabola is going to frown. So we're trying to find this point right here. How do you find the vertex of a quadratic in standard form? Nice job. So that's the x value, though. This is the number of times he has to reduce his price. If you think back to what x originally stood for in the beginning. So he's going to reduce the price by $8. But the question asks us, what is the maximum weekly revenue? So this is where that maximum point is going to occur. Now we need to find the y value that corresponds to that. And I think, Hannah, you said it, right? You just plug it back in. So you just take your 8, and you're going to plug it back in for x in your equation. So we're going to find f of 8. And you number crunch that a little bit. Oops. Watch your order of operations. So you square your 8, multiply it by negative 20. And what we get out of that, $14,850. $14,850 would actually be his maximum revenue. So to finish this problem, you do have to write the answer as a sentence. It says, how can the owner of the go-kart track maximize his weekly revenue? So we now know what that maximum revenue is. How can he get there? Hi, Maddie. Yes, very good. And I did just answer it just like that. I said the owner would reach a maximum revenue of $14,850 by reducing the cost to $27 per racer. And I said $27 per racer because that's $8 away from 35 bucks. Looks pretty good. Okay, so take a look at, you always want to kind of go back and take a second to read through how we did this thing. And we did follow our 7-step process for word problems here. Start to finish, we listed out what we knew and what we didn't. We have a verbal model, and we used it to build an equation. We had to think a little bit about what we actually had to find to solve it. So with that, I guess the question I have for you is, do you have any questions about this whole process? Maybe let's set up the next one. I'm going to adjust your homework assignment for a little bit. We didn't get to the physics problems and the engineering problems. We're going to save those for tomorrow. What I need you to do is finish all of the geometry problems tonight, and then all of the finance problems tonight. So I think that only gets you up through number 7. Yeah. So you only have a couple. I was thinking maybe we could close out today by reading this next one together and maybe even writing the equation. Get you through the hard part. So online music. Grabbed iTunes. An online music store sells about 4,000 songs each day when it charges $1 per song. Ooh, ding. 10:28, huh? Nah. But yeah, so does everybody know what your homework is for tonight? Try a couple of these on your own. If you need to watch the video again to get you through it, it's not a bad idea. And we'll talk more about word problems again tomorrow.